your exit ticket. And if the other classes are any indication, you guys are going to have a lot of fun with this problem. But a couple things, don't forget, Monday your homework is due, the composition of functions that you received, bless you, earlier in the week. Then Tuesday we'll have a quiz over composition of functions. Now you picked up the homework for inverses today. That'll be due on Wednesday, so that'll give you a few extra days to complete that beyond composition of functions. And then right now, Friday of next week is when I have a quiz for inverses scheduled. Okay, so we should start the second 6 weeks with 3 grades. And let's go ahead and wrap up inverses. How far did we get with this problem here? Okay, so all we did was have to solve it algebraically? Is all we done? Okay, that's all we have. Okay, so just for the sake of time, I've already got the compositions here. Now the questions come up every time we go ahead and find an inverse. Do we have to do this? And the answer is no. This is if you are given 2 random functions and the question is given, are they going to be inverses? Okay, well, you can use composition to go ahead and determine that. Now, you should be able to plug one equation directly into the other, as we were doing earlier this week, and it should simplify down to just x. So you'll notice on the left side, I plugged the inverse function we found yesterday into the original function. Okay, it did simplify to x. And then over here on the right, I plugged the original function into the inverse we found yesterday. Okay. Distributed across the parentheses, the 2's canceled, square root of x squared is x again. So we are confirmed they are inverses of each other. Okay. And we'll go ahead and do this same thing for our last problem. We got one problem left. That'll wrap up our review unit. We start trig on Monday. Yay. Is everybody ready, or do you need a few more seconds? I'll take that silence as we're okay. All right. Here is our last problem. G of x is equal to cube root of x plus 2 minus 1. Okay, so everything we did on the previous problem, we want to go ahead and do here. So I'm going to start with a sketch. But what parent did this function come from? Okay, the cube root of x. All right, so I'm going to go ahead and start with that. I'm going to sketch the parent, and then I'm going to go ahead and apply the transformations. I think that'll just make it easier. So we have 0, 0. The cube root of 1 is 1. Cube root of negative 1 is negative 1. Cube root of 8 is 2. And cube root of negative 8 is negative 2. Okay, so the cube root of x, you're looking at something like this. All right, looks like that elongated s. Okay. Now, it's not going to move those points, or at least I don't believe it's going to. But what 2 transformations do we notice here? Okay, so the entire graph is moved left 2 and down 1. So all these points are moving the same distances, the same direction. So I'm just going to focus on the point at the origin here, this 0, 0. So let's see if I go ahead and move it 2 to the left and then 1 down. Probably going to look something like that. Okay. All right. Oh, got the red pen. Okay. So there is my function, the cubed root of x plus 2 and then minus 1. Okay. So first thing, we need to know if this is 1 to 1. So I got a horizontal line here. I'm going to start moving it up and down. Okay. Am I ever hitting this in 2 or more places at once? Okay. Now it looks like it gets kind of close down here. Remember, I'm not the world's best artist. It should continue to go down to negative infinity. So this one passes the horizontal line test. It does not touch it in 2 or more places at once. So what does that mean, actually? That means that my inverse is a what? My inverse guaranteed is a function. Now on yesterday's problem, it didn't pass the one-to-one. Okay, it wasn't maybe step back. It didn't pass the horizontal line test, so it was not one-to-one. So in order to ensure that my inverse was a function, we restricted the domain of that original parabola. Here it's one-to-one. The inverse is a function. We do not have to worry about that. We can just move right on in the problem. In fact, how would I find the inverse? Flip x and y. So g of x does represent my y value. So I'm going to say x equals the cubed root of y plus 2 and then minus 1. Okay. And then now we just go ahead and solve for y, which, what would be the first step? Okay, add the 1, so x plus 1 equals cube root y plus 2. Now what? Okay, cube it. That's going to get rid of a cube root. Okay, so I'm going to cube that binomial. I'm going to cube this. So those will cancel. And the questions also come up, do we need to expand that cube? You do not. Unless you're looking for the practice, I would, in fact, would just go ahead and leave it as is. So I would say x plus 1 cubed is equal to the y plus 2. And it looks like my final step is just to subtract that 2. So x plus 1 cubed minus 2 equals y. There we go. So there's my inverse. Now, we did say that this is a inverse what? It is an inverse function. Remember, the original g was 1-to-1. Okay, he passed the horizontal line test. So only if you end up with a function can you put in that function notation. Now, in this problem, I'm not going to really worry about domain and range because for g, domain is all reals. Okay, the range is all reals. So if you switch those x's and y's, it's not going to look like anything changed. Okay, so I know that the inverse is infinitely tall and infinitely wide as well. But the last thing I want to do on this problem is have you guys work with the function composition. All right, so there is the inverse that we just found. The original problem, the square root of, what was it, x plus 2 minus 1? That was function g. So now I need to show these two. First, g of g inverse of x. And then I want to show g inverse of g of x. Okay. I want to show that the composition works both ways, that I simplify to x, and they are, therefore, inverses of each other. Okay. Now, just for the sake of time, in fact, what I'd like to do is get some people up here to kind of help me out, but I'm just going to go ahead and walk you through this because I think the more time you have on your exit ticket, the better it's going to be for you. All right. So the first thing here, what's my inside function? Okay. All right. So I'm going to take this inverse equation and I'm going to plug it in to that x right there. Okay, so I'm going to have this large cubed root. So this first x is this whole equation. X plus 1 cubed minus 2. Now remember, that's just the x. And then we have the plus 2. Is everybody okay with what I did? Okay. Well, what do you notice immediately? Okay, minus 2 plus 2, those cancel. So they're no longer part of the radical. What's the cube root? Oh, I forgot something, didn't I? Yeah, I forgot the minus 1 on the outside. My fault. Okay, so they're no longer part of the radical. What's the cube root of x plus 1 cubed? Simply x plus 1. Yeah, the cube and the cube root cancel. So I've got x plus 1 minus the 1 on the outside. So when those cancel, there's my x. And remember, it's not a coincidence that I get x. He's the line of symmetry for a graph and its inverse. Okay, now I want to do the exact opposite. I want to take g's equation, this one here, and I want to plug him into the inverse. Okay, the opposite of what I did. So I'm going to have this big parentheses here. So instead of that first x, I'm going to go ahead and say the cube root of x plus 2 minus 1. So that's just the x. Then I have the plus 1. All of that's cubed. And outside we have that minus 2. Everybody okay with what I did? Well, what do you notice? Okay, so the 1s are immediately gone. So this leaves me the cube root of x plus 2 cubed, where those cancel. So I'm left with the x plus 2, and then we have the minus 2 on the outside. So there we go. So it has to simplify down to a positive 1x. Any variation of that, and they are not inverses. Okay. Well, the only thing left is just to go ahead and sketch it. I think for that I will get somebody up here because you've seen how good of an artist I am. All right. So here's the original function. Who wants to come on up and show me the sketch of the inverse we found? A cubed root, or excuse me, x plus 1 cubed minus 2. Connor, you want to do it? All right. So what is this graph going to look like if I reflected it across y equals x? Okay. All right. We're close. Okay, it's not quite there. Because imagine if I were to fold along this line, are the two parts going to come together perfectly? Not quite. Okay. There's just one thing we would need to do to your graph, and it's going to be perfect. Natalia, you want to try? Okay. That's all.
I don't know, actually. I lied to you. I don't
Okay.
I thought and then I didn't know. Okay.
Okay, well, she's running back to her desk. Okay.
Yeah, sorry.
That's okay. All right, well, let's do this. And what can sometimes help people is just taking points off the original and inverting them. Like, for example, we know that this point got moved to -2, -1. So if -2, -1 was on the original graph, what's on the inverse? -1, -2. Okay, so it's probably going to look something like that. Okay. Now see, does that look a little more symmetrical? Okay. And think about the function that we ended up with. Okay. This is the inverse. Well, remember x cubed curves up to the right like that. Well, what transformations do we notice here? It went left how far? Left 1, down 2 to the point that I actually changed. So here we go. Okay. How we doing? Good, good, good. All right. Well, good. Okay.